The industrial heartland of Germany, particularly the Ruhr region, represented a vital target for the Allied war effort during World War II. British war planners understood that to effectively incapacitate Germany's massive industrial machinery, they needed to strike at key infrastructure. Among the most tempting and critical targets were the vast dams of the Ruhr industrial region. The military goal was clear: to blow up these dams or strike them with powerful bombs, causing breaches that would unleash catastrophic flooding downstream. Such an outcome would severely disrupt power, water, and manufacturing output, crippling the German war machine. Achieving this objective, however, required a radical new approach to aerial warfare. Dams are massive structures, and attacking them presented unique challenges, particularly the danger of anti-torpedo nets placed by the Germans, who recognized the vulnerability of these installations to conventional torpedo attacks. This difficult engineering challenge required an inventor with vision and determination. That individual was aircraft designer Barnes Wallis. Wallis, working independently of initial British war planning, began contemplating this problem around 1941. His calculations led him to a groundbreaking conclusion: the most effective way to inflict maximum damage on a dam was to utilize a shock wave. Critically, this shock wave needed to originate from an explosive detonating underwater, pressed directly against the dam structure. The essential dilemma became delivering a large explosive device that could be carried by an existing Royal Air Force bomber, yet possess the capability to evade the submerged anti-torpedo defenses and ultimately breach the massive concrete and earth structures. The solution conceived by Wallis was elegant and revolutionary: a bomb designed to skip across the surface of the water, thereby avoiding the nets entirely. By the following year, Wallis had determined that skipping the bomb was the key. Extensive scale tests were conducted to perfect this technique, revealing that applying backspin to the cylindrical weapon was absolutely critical for ensuring a successful delivery run. The technology and engineering. The final design of this specialized weapon, codenamed Upkeep, was formidable. It was a cylindrical, air-dropped bomb measuring 60 inches in length with a diameter of 50 inches. The total weight of the Upkeep bomb was a massive 9,250 pounds. Of this weight, the explosive content itself accounted for 6,600 pounds. This explosive material was the powerful Torpex, encased within a steel shell 3/8 of an inch thick. To ensure the shockwave detonated at the optimal depth for maximum structural damage, the weapon incorporated 3 Mark IV hydrostatic pistols. These pistols were engineered to trigger the explosion precisely when the bomb reached a depth of 30 feet beneath the surface. Furthermore, because of the extreme value and secrecy surrounding the weapon, a self-destruct pistol was also installed to prevent the bomb from falling intact into enemy hands should the mission fail or the aircraft be lost. In testing in early 1943, this immense bomb could indeed be carried by the 4-engine Avro Lancaster heavy bomber. By this stage of the war, the Lancaster had already established itself as the reliable backbone of the Royal Air Force's bomber force.
In general characteristics such as length and wingspan, as well as performance metrics like cruising speed, the Lancaster bore some similarities to the principal heavy bombers utilized by the United States military. These American counterparts included the Boeing B-17G Flying Fortress and the consolidated B-24J Liberator. However, while the Lancaster possessed a notably heavier payload capability, its service ceiling was significantly less than that of the American aircraft. The Lancaster's service ceiling was 21,400 feet, which was considerably lower than the Boeing B-17G's ceiling of 35,600 feet or the consolidated B-24J Liberator's ceiling of 28,000 feet. To prepare for Operation Chastise, the standard Lancaster needed serious modifications to accommodate the specialized Upkeep weapon, which weighed 9,250 pounds, or according to another description, 8,850 pounds. The Royal Air Force placed an initial order for 30 aircraft to undergo these changes, though this number was later reduced to 21 bombers. These modified aircraft were designated the Type 464 provisioning. They were fitted with American-built Packard Merlin 28 engines. The necessary changes were extensive. Due to the sheer size of the cylindrical bomb, the standard bomb bay doors had to be entirely removed. V-shaped caliper arms were installed beneath the fuselage to securely hold the massive weapon. The most intricate modification related directly to the bouncing mechanism. A specialized Vickers variable speed hydraulic gear was installed. This gear was essential as it drove the belt that imparted the required backspin to the bomb. The precise speed required for success was determined to be 500 revolutions per minute. Additionally, to minimize the aircraft's overall weight and aerodynamic drag, the mid-upper turret was completely removed and the resulting hole was covered. Planning the impossible attack. With the weapon and the specialized aircraft ready, the operational phase, named Operation Chastise, was formally put into motion by the Royal Air Force on February 28, 1943. The operational window was tentatively scheduled to take place between May 14th and May 16th. This timing was deliberately chosen because during this specific period, the water levels in the targeted dam reservoirs would be at their absolute highest. A breach during this window, therefore, would guarantee the greatest possible volume of flood damage. The Royal Air Force selected a highly decorated veteran, Wing Commander Guy Gibson, to take command of the newly formed No. 617 Squadron of No. 5 Group. Gibson, in turn, meticulously selected 21 experienced crews, pulling them from various group squadrons. The squadron was based at Scampton, located in the East Midlands of England. Gibson informed his chosen airmen that their mission would involve targets demanding exceptional proficiency in low-level night flying. To facilitate the intense training and improve overall aircrew efficiency for this unprecedented task, the Royal Air Force took the extraordinary step of suspending standard flying regulations. The success of the mission hinged on achieving precise delivery parameters. Through extensive tests conducted with inert bombs, Barnes Wallis calculated that the upkeep bomb needed to be released from a height of exactly 60 feet, while the bomber maintained a speed of 220 miles per hour. The immense difficulty lay in the fact that no standard bomb sight or altimeter then in use by the Royal Air Force possessed the necessary accuracy for such an extremely low-level attack. Early trials demonstrated the severe risks involved. During a practice run at the Reculver bombing range, a Lancaster released a dummy upkeep bomb. The resulting water plume created upon detonation or impact was significant enough to cause damage to the aircraft itself. The inventor, Barnes Wallis, along with Royal Air Force personnel, watched as the dummy bomb successfully skipped toward the shoreline. Solving the critical bomb sight problem fell to Wing Commander Charles Dan. He devised a remarkably simple yet effective solution. He constructed a handheld triangular device made primarily of wood. This device had a sighting hole situated at its apex. The opposite base of the device featured nails positioned at various points. When these nails were lined up precisely with the dam's two sluice towers, the device effectively fixed the exact release point required for the bomb. Determining the required 60-foot altitude presented a different challenge. The solution was ingenious: the employment of two powerful Aldous spotlights. One spotlight was carefully installed in the nose of the Lancaster, and the second was placed behind the bomb bay. These lights were angled specifically so that when the aircraft was flying at the precise height of 60 feet, the two beams would converge to create a perfect figure-8 pattern visible in front of the starboard wing.
Bomb testing commenced on April 16th at the Reculver testing ground. As the month concluded, the newly formed squadron began flying the specialized modified Lancasters. Wing Commander Gibson was given a detailed debriefing in April regarding the potential German targets. The intense low-level flight testing phase quickly exposed operational vulnerabilities. The standard radio sets proved unreliable when operating at such exceptionally low altitudes. To rectify this dangerous deficiency, engineers swiftly exchanged the standard equipment for very high-frequency radio sets. Wing Commander Gibson also made a crucial decision regarding the aircraft's defensive armament. He decided that the Lancaster guns would exclusively use tracer rounds. The reasoning behind this was strategic. The highly visible tracer rounds were expected to serve as a psychological deterrent, intimidating the German anti-aircraft gunners more effectively than rounds they could not visually track. The squadron progressed through the final stages of training. On May 11, No. 617 Squadron successfully dropped inert bombs for the first time. Up until that point, all of the demanding trials have been conducted solely by specialized test pilots. The final and only test involving a live explosive bomb took place just 2 days later.
The night of the attack. The weather forecast for the targeted region of Germany during the proposed strike dates appeared favorable. The Royal Air Force made the final, crucial decision to proceed with the mission on the night of May 16th. Barnes Wallis arrived at the Scampton base to personally oversee the critical tasks of arming and loading the unique weapons into the waiting aircraft. During this process, a moment of acute danger occurred. While a bomb was being loaded, it accidentally fell to the ground. Fortunately, the bomb did not explode, averting what could have been a catastrophic event on the airfield. May 16 was a day filled with intense preparation. Pilots, navigators, and bombardiers gathered for meetings with both Wing Commander Gibson and inventor Barnes Wallis. Wallis took time to explain in detail exactly how the unique bomb worked and what outcome was anticipated upon detonation. The main objectives for Operation Chastise were clearly defined: the Möhne, Eder, and Sorpe dams. Should any primary targets prove inaccessible, alternate targets were designated, including the Lister, Ennepe, and Daimel dams. The crews were also carefully debriefed on the differing construction types of the dams they were assigned to destroy. The Möhne, Eder, Lister, Ennepe, and Daimel dams were all categorized as gravity dams. These were massive structures built from masonry and concrete, relying entirely on their immense weight to hold back the water. To destroy this type of dam, the bombers were instructed to line up their attack runs so they flew directly over the reservoir, allowing the bomb to skip across the surface. The Sorpe dam, however, presented a completely different engineering challenge. Sorpe was an earthen dam, meaning it had a central concrete core supported on both sides by sloping earthen ramps. For Sorpe, Wallis had determined that the bomb would be dropped without the backspin mechanism engaged. Instead of skipping over the water, the pilots were to fly the length of the reservoir and drop the bomb near the dam's crest. The final briefing for the air crews took place at 6 o'clock in the evening. The mission was organized into 3 distinct waves of aircraft.
The first wave was composed of 3 flights, each consisting of 3 Lancasters. This first wave took a southern route toward the targets. Their primary task was to strike the Möhne Dam first, then proceed to the Eder Dam. If any aircraft in the fight still retained their bombs after those strikes, they were authorized to attack the Sorpe Dam. The commanders leading the 3 flights in this first wave were Wing Commander Guy Gibson, Flight Lieutenant John Hopgood, and Flight Lieutenant Harold Martin. The second flight was led by Squadron Leader Henry Young, Flying Officer David Maltby, and Flight Lieutenant Dave Shannon, taking a northern route. The third flight commanders were Squadron Leader Henry Maudsley, Flight Lieutenant William Astell, and Flight Lieutenant Les Knight. The second wave had the Sorpe Dam as its primary objective. This wave comprised 5 aircraft, departing at strict 1-minute intervals. The commanders in this wave were Squadron Leader Joe McCarthy, Flight Lieutenant Norman Barlow, Flight Lieutenant Les Monroe, Flight Lieutenant Vernon Byers, and Flight Lieutenant Jeff Rice, taking a northern route. The third wave was composed of 5 aircraft and served as the mission reserve. This final wave was scheduled to depart 90 minutes after the second wave. The reserve commanders were Flight Lieutenant Warner, Flight Lieutenant Louis Burpee, Flight Lieutenant Ken Brown, Flight Lieutenant William Townsend, and Flight Lieutenant Cyril Anderson. The plan was for the Royal Air Force to radio them their specific targets while they were already airborne. At precisely 9 o'clock in the evening on May 16, 1943, the prearranged signal was given, and the crews of the first wave boarded their specialized aircraft. A small mechanical emergency complicated the departure. Squadron Leader McCarthy's aircraft in the second wave developed a mechanical failure. His crew had to swiftly transfer to the sole backup aircraft available. Unfortunately, this backup bomber lacked both the crucial very high-frequency radio set and the unique ALDA spotlights necessary for precise altitude finding. Due to the significantly longer route required for the second wave, they departed first, ticking off at 9:28 p.m. The first wave, led by Gibson, followed 11 minutes later. The third reserve wave, however, did not take off until 9 o'clock the following morning. It is important to note that 1 aircraft in the third wave was tragically shot down by enemy anti-aircraft fire during its flight. The attacks on Möhne and Eder. The crucial action began at the Möhne Dam. Wing Commander Gibson successfully completed a test run before committing to the live attack. He lined up the Möhne Dam and released his bomb. The weapon bounced 3 times across the water surface before it sank and then exploded. Despite the successful drop, the bomb detonated too far away from the dam structure. Critically, no breach occurred. However, the explosion did achieve one vital success. It completely destroyed the protective anti-torpedo nets surrounding the dam. The next aircraft, piloted by Flight Lieutenant Hopgood,
faced immediate heavy resistance. His plane was struck by the dam's ferocious flat guns during the approach run. As a consequence of the damage, his bomb was dropped too late. It bounced over the top of the dam structure and landed harmlessly near the power station situated behind the dam. The subsequent explosion successfully destroyed the power station. Tragically, Hopgood's Lancaster immediately caught fire and blew up. 3 of his crewmen were able to escape the burning wreckage, and 2 of them survived and were taken captive. Flight Lieutenant Martin made his run next, but his bomb veered too far off center before exploding. The massive Möhne Dam remained visually undamaged by this attempt. Squadron Leader Young followed, and his bomb successfully struck the dam. It sank and then detonated. Although the bomb hit its target correctly, it did not appear to have caused any immediate structural damage.
By this time, Flying Officer Maltby was making his approach. As he released his ordnance, he noticed the dam structure was finally beginning to crumble. His bomb bounced 4 times before it struck the dam itself. It sank and detonated. The resulting explosion, like the previous 4, sent a gigantic geyser of water high into the air. At this critical juncture, Wing Commander Gibson ordered Flight Lieutenant Shannon to prepare for his own run. However, before Shannon could begin his attack, Gibson's keen eye spotted a large volume of water aggressively pouring off the opposite side of the dam. He then realized that there was a massive hole in the previously impenetrable structure. Möhne Dam had been breached. Gibson immediately called off Shannon's attack. He swiftly notified Group 5 headquarters that the Möhne Dam had been successfully breached. He then ordered Maltby and Martin to turn their aircraft around and head for home. Gibson ordered the remaining aircraft to follow him onward to the second major target, the Ader Dam. The 5 remaining aircraft reached the Ader Dam, encountering no opposition whatsoever. This was fortunate, as the approach to Ader was structurally difficult for the pilots, but the dam lacked any enemy air defenses. Flight Lieutenant Shannon was the first to attempt an attack at Ader. He made several aborted runs before finally releasing his bomb. The weapon exploded next to the dam, but the massive structure remained completely intact. Squadron Leader Maudsley followed with his attempt. His bomb was dropped so late in the run that it tragically struck the dam's parapet. The resulting detonation caused severe, crippling damage to his aircraft. Maudsley's Lancaster was never seen again. Only Flight Lieutenant Knight remained. After one necessary aborted run, he managed to release his bomb. It bounced 3 times, striking the dam slightly to the right of the center point. It then sank and detonated underwater. Gibson waited in agonizing silence for the outcome. After what he described as seeming like an eternity, he watched the Ader Dam violently break. He recalled the sight as being as if a gigantic hand had pushed a hole through cardboard. Gibson quickly notified Group 5 that the Ader Dam had also been breached. At that point, the 5 remaining aircraft from the Möhne Ader strike turned toward home. Tragically, during the return leg of the journey, Squadron Leader Young's aircraft was shot down off the coast of Holland. The difficult second and third waves. The second wave faced an immediately more arduous journey. They were required to fly close to the heavily fortified island of Texel, which was bristling with concentrated anti-aircraft guns. Flight Lieutenant Barlow was the first commander in the second wave to reach German territory, but tragically, his aircraft subsequently disappeared. A dangerous security breach also occurred. For reasons that remain unknown, the self-destruct mechanism installed in Barlow's bomb was never armed. This allowed the Germans to recover a completely intact upkeep bomb, which they were then able to study and attempt to reverse engineer. Flight Lieutenant Munro's Lancaster suffered heavy damage. After crossing Vineland, located in northern Holland, his aircraft was struck by enemy flak. The damage caused a complete loss of both internal and external communications. Furthermore, power was cut to the tail turret. With no means of communication and a drastically decreased defensive capability, Munro was forced to abort the mission and return to Scampton Base. His landing at Scampton was nearly catastrophic, as he cut in front of another returning aircraft. Group 5 headquarters lost all contact with Flight Lieutenant Byers shortly after his takeoff. He drifted too close to the heavily defended island of Texel and was subsequently downed by flak fire. Flight Lieutenant Rice was flying over the Waddenzee, which is an intertidal zone running along the Dutch coast. Here, he and his crewmen encountered severe difficulty accurately judging their altitude above the water. They inadvertently struck the surface of the water, and the collision violently tore off their bomb. Having lost their critical ordnance, Rice was forced to turn back to Scampton.
Squadron Leader Joe McCarthy, after the mechanical delays earlier, finally reached the Sorb Dam. He was puzzled to find that there was no sign of any prior attack in progress.
Despite having good visibility and, thankfully, the absence of enemy air defenses, McCarthy faced a formidable challenge. He had to make several long runs along the dam because his backup aircraft lacked the precise ALDA spotlights needed for altitude determination. On his 10th arduous run, McCarthy successfully dropped his bomb. Following the specialized instructions for an earth dam, the bomb was dropped without backspin along the center of the dam on the water side. It rolled down the slope and exploded. McCarthy observed crumbling damage along the top of the dam structure, but crucially, no breach occurred. As the third wave reserve aircraft reached the continent, they received their specific targets via radio transmission. Flight Lieutenant Otley was leading this final wave. Shortly after being directed to the Lister Dam, his aircraft was hit by flak. Before the Lancaster exploded, one crew member managed to escape and was captured by the enemy. Flight Lieutenant Burpee strayed perilously close to the Luftwaffe's Gilles-Orion Air Base. His aircraft was hit by concentrated flak fire and crashed near the base perimeter. Meanwhile, Flight Lieutenant Ken Brown received instructions to head for the Sorp Dam. After numerous aborted runs, mirroring the difficulty faced by McCarthy, Brown managed to successfully drop his bomb near the dam's center point. Circling back to assess the damage, he noted that the top of the dam was crumbling over a greater length than it had been after the strike by Maltby's bomb. Flight Lieutenant Townsend was instructed to target the Enopy Dam. However, he immediately encountered difficulty in accurately locating the correct dam. He spotted a lake that contained a spit of land within it. The crew knew that the Enopy Reservoir was supposed to contain an island, and they ultimately concluded that they had located the correct dam. The bomb they dropped exploded short of the parapet and failed to cause any structural damage. It was later verified that Flight Lieutenant Townsend had mistakenly attacked the Bever Dam. Finally, Flight Lieutenant Cyril Anderson was initially directed to the Dimel Dam, but his target was then rerouted by radio to the Sorp Dam. Already off course due to the necessary evasion of flak, he then encountered a heavy, thick mist that obscured the entire region. Having significant trouble getting properly oriented, and with the light of dawn rapidly approaching, Anderson made the decision to abort the mission and return safely to Scampton. The returning aircraft began to land. Flying Officer Maltby, who had delivered the successful breaching bomb at Moan, landed the first aircraft back at Scampton Base at 3:11 a.m. Flight Lieutenant Townsend landed the final returning aircraft at 6:20 a.m. The immediate aftermath and assessment. The success of the mission, particularly at the primary targets, became evident almost immediately. A reconnaissance flight conducted on the same day as the mission revealed scenes of massive flooding behind both the Moan and Eder dams. The structural damage was catastrophic. 87% of the water that had been held in the Moan Reservoir had been violently released. The damage at the Eder was similarly immense, with 75% of the reservoir's water having escaped.
The reconnaissance photographs provided stark evidence of the scale of the destruction. For miles around the breached dams, power stations, factories, crucial roads, bridges, and pumping stations were observed to be either completely destroyed or severely damaged. As a direct result of the breaches, the supplies of gas, electricity, and drinking water were severely interrupted throughout the region. The human cost of the flooding was also tragic. The total casualties amounted to 1,341 people, the vast majority of whom were foreign workers who had been relocated to the industrial Ruhr Valley. Germany's reaction was swift and serious. Albert Speer, who served as Germany's Minister of Armaments and Munitions, arrived on the scene immediately following the attack to determine the exact extent of the damage inflicted. German leader Adolf Hitler, recognizing the severity of the industrial disruption, quickly approved an emergency response. 7,000 workers were immediately dispatched to begin the massive cleanup effort and to commence the difficult process of rebuilding the destroyed dams. Hitler also authorized the transfer of an additional 20,000 workers to assist in this recovery. Many of these skilled laborers were rerouted from vital Atlantic Wall construction projects to focus entirely on the urgent dam repairs. A Royal Air Force reconnaissance photo taken after the raid clearly showed the Moni Reservoir almost entirely drained, underscoring the success of the mission. The scale of the German effort to mitigate the damage was evident in the deployment of resources. Hitler's authorization led to the transfer of thousands of workers who were tasked with cleaning up the flood damage and undertaking the vast project of rebuilding the dams. In the immediate aftermath of the strikes, the German military made a significant commitment of resources to defense. They deployed the equivalent of an entire division of soldiers, specifically to defend the remaining Ruhr dams against any future attack. Furthermore, they installed extensive anti-aircraft guns at all of the remaining dam locations. The courageous Operation Chastise, while a technical triumph, came at a heavy cost to the Royal Air Force. No. 617 Squadron incurred substantial losses. 8 Lancasters were lost during the mission, resulting in 56 casualties among the highly trained airmen. Strategic implications and historical debate. The true strategic effect of Operation Chastise on the overall German war effort has remained a complex and active source of debate among British military experts and historians. One school of thought suggests that the heavy losses incurred by No. 617 Squadron were ultimately in vain. Proponents of this view point to the rapid German response. The gaps successfully blown into the Moni and Eder dams were patched up and repaired by the following October. A detailed post-war analysis attempted to quantify the industrial impact. This analysis estimated that the Germans suffered as little as 5% loss of armament output during the latter half of 1943. If this low figure is accurate, the high cost in aircraft and lives might be viewed as disproportionate to the strategic gain. However, other military experts hold a distinctly more positive view of the operation's strategic results. They emphasize that the mission achieved a vital success, largely because of the substantial quantity of resources, both construction materials and, most importantly, skilled labor, that the Germans were forced to commit immediately to rebuilding the dams. This argument centers on the massive diversion of German military and industrial resources away from other critical war projects, such as the Atlantic Wall. The emergency repairs required the immediate transfer of 7,000 workers, followed by an additional 20,000 workers, all dedicated to mitigating the flood damage and rebuilding the infrastructure. This sudden, compulsory diversion of manpower and materials represented a significant setback to other German defense and production schedules. Regardless of the precise long-term economic impact, Operation Chastise remains a profound technological and operational achievement of World War II. The mission demonstrated an exceptional level of ingenuity and bravery. The unique concept of the bouncing bomb, coupled with the specialized modifications of the Avro Lancaster, pushed the boundaries of military engineering. The Royal Air Force successfully built upon the high standards and achievement established by No. 614 Squadron during Operation Chastise. The specialized expertise developed during the mission, particularly in precision low-level flying and specialized ordnance delivery, was utilized in subsequent critical strikes. These included vital missions against German V-weapon sites and the decisive attacks launched against the massive German battleship Tirpitz. The technological challenge of the dams required highly specific and unprecedented engineering solutions. The constraints of needing a bomb that was small enough to be carried by an existing aircraft, yet powerful enough to breach the dams while evading anti-torpedo defenses, drove Barnes Wallis's unique design. The decision to use backspin to skip the bomb, confirmed through scale tests, was the mechanical heart of the solution. The upkeep bomb itself was a masterpiece of specialized destruction. Its 9,250-pound weight, including the 6,600 pounds of Torpex explosive, made it one of the largest specialized ordnance carried by the Lancaster. The requirement for underwater detonation at precisely 30 feet, controlled by hydrostatic pistols, was crucial for generating the necessary shock wave against the concrete. The potential security risk of losing such a unique weapon necessitated the inclusion of a self-destruct pistol. The modifications to the Avro Lancaster, transforming it into the Type 464 provisioning aircraft, were complex and demanding. The removal of the bomb bay doors and the mid-upper turret were necessary sacrifices for weight reduction and fit. The Vickers variable-speed hydraulic gear, responsible for achieving the 500 revolutions per minute of backspin, was the key functional enhancement that enabled the skipping mechanism to operate successfully. The operational difficulties related to achieving the exact release height of 60 feet at 220 miles per hour underscored the limitations of existing wartime technology. The fact that the bomber crews had to rely on a homemade, handheld wooden triangle for aiming, designed by Wing Commander Charles Dan, speaks to the improvisation required. Similarly, the reliance on the converging figure-8 pattern created by the two Aldous spotlights, one in the nose and one behind the bomb bay, as the sole accurate altimeter for the 60-foot altitude, demonstrates the extreme measures taken to meet the mission's precise requirements. The training regimen was intensive and highly unusual, necessitating the suspension of standard flying regulations to improve aircrew efficiency in low-level night flying. The test runs, such as those at the Reculver bombing range, were vital for confirming the operational risks, including the danger of the water plume damaging the aircraft upon the bomb's impact. The decision to switch to very high-frequency radio sets, due to the unreliability of standard equipment at low altitude, further illustrates the mission's technical demands. The successful execution required coordination across numerous fronts: engineering, logistics, operational planning, and unparalleled airmanship. The differentiation in attack profiles based on the dam structure types was a crucial element of the pre-mission briefing. The 5 gravity dams, Möhne, Eder, Lister, Eni, and Diemel, built of concrete and masonry, required the skipping, spinning bomb dropped over the reservoir. In contrast, the earthen Sorpe dam, with its central concrete core, demanded a non-spinning bomb dropped near the crest with the pilot flying the length of the dam rather than over the reservoir. The chronological sequence of the raid illustrates the dedication and the hazards faced by the airmen. The departure was complicated by mechanical failure for Squadron Leader McCarthy, highlighting the fragility of relying on complex, modified aircraft. The success at Möhne came only after multiple attempts. Gibson's initial bomb failed to breach the dam, but crucially destroyed the anti-torpedo nets. Hopgood's tragic loss, although destroying a power station, revealed the deadly accuracy of the dam's flak defenses. It was Maltby's bomb, the 5th attempt, that finally delivered the decisive blow, causing the structure to crumble and leading to the massive breach. The journey to the Eder Dam, though encountering no direct opposition, presented environmental challenges. The dam lacked air defenses, a fortunate circumstance, given the difficulty of the approach. The loss of Maudsley, after his bomb struck the parapet, emphasizes the razor-thin margin for error inherent in the low-level delivery technique. Knight's successful delivery at Eder, which resulted in the dam breaking open as if a gigantic hand had pushed a hole through cardboard, secured the primary objective of the mission. The subsequent shooting down of Young on the return leg served as a stark reminder that the danger remained constant even after leaving the target area. The second wave's experience showcased the challenges of flying a heavily defended route and the critical failures that plagued the mission. The loss of Barlow's aircraft and the subsequent recovery of an intact upkeep bomb by the Germans presented a significant intelligence failure for the Allies. Monroe's damage and forced return, and Bayer's fate near Texel, emphasized the lethal density of German anti-aircraft positions. Rice's difficulties in accurately judging altitude over the Wadden Sea, leading to the loss of his bomb, confirmed the vital role played by the specialized Aldous spotlights. McCarthy's successful 10th run at Sorpe, despite the lack of necessary aiming lights, proved the tenacity of the crew. The reserve wave faced its own dangers and navigational errors. The losses of Otley and Burpee to flak illustrate that even as the reserve, the mission remained highly lethal. Brown's success at Sorpe, causing greater crumbling damage than previously observed, added to the overall disruption. Townsend's mistake in attacking the Bever Dam instead of the intended Ennepe-Am underscores the navigational complexities of night operations. Even with precise intelligence, Anderson's struggle with heavy mist and approaching daylight was a common difficulty faced by aircrews operating under extreme pressure and specific time constraints. The immediate results, documented by reconnaissance, vividly demonstrate the catastrophic success against the gravity dams. The release of 87% of Möhne's water and 75% of Eder's water confirmed the mission's physical objective. The collateral destruction, the demolition of power stations, factories, and transport links, validated the strategic premise that striking the dams would cripple the industrial infrastructure miles away. The German reaction, orchestrated by Albert Speer and authorized by Adolf Hitler, confirms the strategic significance of the attack, regardless of the subsequent debate over industrial output percentages. The swift deployment of 7,000 workers, escalating to 27,000, and the mandatory resource transfer from critical defensive works like the Atlantic Wall highlight the scale of the crisis the Germans perceived. The decision to dedicate a division's worth of soldiers and significant anti-aircraft weaponry to dam defense in the aftermath further demonstrates the profound psychological and military impact of the raid. Ultimately, while the debate among military experts regarding the precise long-term output loss continues, some estimating as low as 5% loss of armament output in the second half of 1943, the mission is universally recognized as an extraordinary technological venture. The ability of the Royal Air Force to design, test, and deploy a unique weapon on modified aircraft, executed by highly trained airmen at unprecedented low altitudes, cemented Operation Chastise as one of the great technological achievements of World War II.
The techniques in Specialized Squadron, number 617, went on to fulfill other critical, highly specialized missions throughout the remainder of the conflict. The sheer complexity of the bouncing bomb design, a device that required both horizontal velocity and vertical spin to defeat obstacles, stands as a monument to wartime engineering ingenuity. The necessary speed of 220 miles per hour and the exact altitude of 60 feet were non-negotiable parameters that demanded flawless execution. The fact that multiple crews, using rudimentary sighting devices and improvised altimeters, were able to achieve this level of precision under intense anti-aircraft fire is a testament to the training and the resolve of the personnel involved.
The story of the dam-busting Lancasters is not merely a tale of destruction, it is a profound demonstration of engineering under duress. The modification of the Lancaster, already a cornerstone of the bomber force, showcased its adaptability and robustness. The airframe, designed for high-altitude saturation bombing, was fundamentally re-engineered to carry a single, massive cylindrical payload and operate meters above the water surface. The installation of the D-shaped caliper arms and the hydraulic gear fundamentally transformed the aircraft's operational role. The resulting Type 464 provisioning aircraft was a unique variant, born solely of the need to deliver the specialized upkeep bomb. The selection of Wing Commander Guy Gibson to lead the new No. 617 Squadron was critical. His experience and ability to select highly proficient crews ensured that the demanding requirements for low-level night flying could be met. The crews had to master flying maneuvers that violated standard procedures, pushing the capabilities of both man and machine to their absolute limits. The rigorous training conducted at locations like the Ruhr Valley Dam was essential for preparing the airmen for the actual target terrain. The moment of sheer terror when one of the upkeep bombs accidentally fell during loading underscores the inherent danger of working with such large, specialized explosives. The gravity of the mission was understood by all involved, from Barnes Wallis providing final explanations of the bomb's mechanism to the pilots reviewing the differences between gravity dams and earth dams. The psychological impact of the success cannot be overlooked. Even if the German industrial output recovered quickly, the audacious nature of the strike, coupled with the massive physical destruction and flooding, served as a powerful propaganda tool for the Allies and a severe blow to German morale. The sheer volume of water released, destroying infrastructure for miles around, including roads, bridges, and essential utility stations, was instantaneous and overwhelming. The cost of 56 casualties and 8 Lancasters represents a substantial loss for one mission. However, the commitment of German resources, including experienced construction workers and vital materials pulled from other theaters, served as a tangible strategic disruption that may have slowed other German war efforts. The Germans' response of immediately deploying the equivalent of a division to defend the dams highlights their recognition of the mission's effectiveness as a threat multiplier. In the final analysis, Operation Chastise transcended mere economic calculations. It was a daring demonstration of innovative warfare. The collaboration between the inventor, Barnes Wallis, the engineers who modified the Lancaster, and the elite aircrews of No. 617 Squadron produced a result that remains etched in the history of aerial combat. The mission secured its place not only for the breaches at the Moni and Eder dams, but also for the revolutionary technology and the unparalleled airmanship required to deliver the specialized bouncing bomb. The technological leap represented by the upkeep bomb system paved the way for future precision attacks. The experience gained by the Royal Air Force in mastering the delivery of large specialized ordnance at extremely low altitudes proved invaluable. The legacy of the dam-busting Lancaster is one of persistence, precision, and the willingness to pursue radical engineering solutions to solve impossible military problems. Even today, the story stands as a pivotal example of how ingenuity, when coupled with immense courage, can temporarily shift the strategic balance during a large-scale conflict. The specific modification of the heavy bomber for a single unique purpose showcases the critical importance of adapting technology to meet specific, high-stakes military objectives.
The airmen of the Royal Air Force's No. 617 Squadron, led by Wing Commander Guy Gibson, undertook a mission that was known to be extraordinarily dangerous and technically complex. Their meticulous training, including the use of inert bombs and the single test with a live explosive, prepared them for the highly improbable feat of flying heavily laden bombers at just 60 feet above the water. The success of the mission, despite the inherent risks and losses, demonstrated the power of a concentrated, highly specialized attack against strategic infrastructure. The lasting visual of the drained reservoirs and the breached dams remains a powerful image of technological warfare. The need for the Germans to immediately transfer thousands of workers away from other critical military projects confirms the mission's success in diverting valuable time and resources from the larger German war machine. This groundbreaking operation redefined the capabilities of heavy bombers and demonstrated that technological innovation could overcome seemingly insurmountable defenses, such as the German anti-torpedo nets. The specific requirements, the backspin of 500 revolutions per minute, the precise 60-foot altitude, and the 220 miles per hour speed were variables that had to converge perfectly for the mission to succeed. The fact that 2 major gravity dams were breached stands as the ultimate testimony to the efficacy of Barnes Wallis's concept and the skill of the Royal Air Force crews who executed the plan under fire. The specialized nature of the attack ensured that the Royal Air Force continued to use the Lancaster and the specialist No. 617 Squadron for future precision strikes, recognizing the value of such dedicated, unique capability.